Hi everyone, I'm Robert from Erlang Solutions. I'm here with Dali, and today we are going to talk about the launching of Safe for Elixir. So now Safe is available for both Elixir and Erlang. But first, let's talk a little bit about the secure code base. What is a secure code base and how can you get it? So first of all, you need to keep some guidelines to ensure that you are following some certain standards. We are going to talk about these guidelines a little bit later in the webinar. And also, it is important to design your application in a good way. So by this good design, you can ensure that the things can go most likely in a good way. But in a large code base, you most likely to have many developers. But with these developers, it's not that easy to follow all the standards and ensure that every piece of code is written in the best as possible. Because even if you have the most effort, mistakes can slip through. So that is why it is important to regularly check for vulnerabilities in your source code and also do some security audits. And what makes a code secure? Um, in Erlang and Elixir systems, we often talk about atom creations. So it is important to create the atoms with a sane manner, either by using the existing atom functions or have some guard checks to ensure that you are not creating atoms dynamically. The other thing is that when you are injecting some resource to your system, this can be a file, a script, or something like that, you always check it and you don't run or execute untrusted inputs because then basically a lot of things can go wrong. In Erlang and Elixir systems, we usually have a lot of processes doing different operations. But what is really important when we are spawning these processes, we are linking them in the same operation. That is what we call the atomic process operations. Sometimes we need to use databases as well. Sometimes we use ETS for that. And when we are working with ETS, it is really important to make sure that we are looking these tables properly. And of course, the last one I think goes without saying, when a function is deprecated, we should definitely avoid it because usually they are deprecated for a good reason. So here at Safe, we have these 5 categorizations of the vulnerabilities. These are the denial of service, injections, deprecations, man-in-the-middle attacks, and the race conditions. Denial of service is the first one here. It's usually the atom exhaustion related things when you are using the list to atom, binary to atom, and stuff like that. Injections is when, as I previously mentioned, you are loading scripts into your code, into your system. And yeah, deprecation issues, again, we should just avoid using deprecated functions. In the man-in-the-middle attacks, it is when you configured your system in a bad way, and someone might can get into the SSL handshake. And the last one is race conditions, is the one when you have a bad process prioritization or a bad process linkage. All right, and how to check if your code is safe? First, I told in the beginning that there are some certain guidelines, and here is the one that are mostly used by Erlang and Elixir systems. It is the Secure Coding and Deployment Hardening Guidelines, which is made by the Erlang Ecosystem Foundation. Here it is listed a bunch of possible vulnerabilities, and what you can do is have a text-based search. This is basically just control F-ing in the code base or using grep or something like that. But this gives a lot of false positives, and you need to check everything one by one. Or you can use safe, and safe already reduces you the number of false positives, so you can focus on real issues and fixing them. All right, but how Safe finds these vulnerabilities and how it can eliminate the false positives. So we have a case study, this source code. This is actually from a popular open source project, but of course the function names and the variable names has been changed. And here is the version that's been rewritten into Elixir. So here we have the string to atom or the list to atom call. And this is our possible vulnerability. We call it a candidate. We need to check what happens in the argument of the function call. And we see that there is a binary to list in the case of Erlang version, or a to-string call in the case of Elixir version. If we go further, we see that in the parameter of those function calls, there is the variable f, which is coming from the lambda or the function header, or from the list comprehension. Okay, but that's also coming from somewhere. And in both cases, it is coming from the maps to list, or like in the Elixir variant, the map to list. And we need to continue our investigation. So we need to check the parameters of this function call, and that is the variable b. And we can see that that is coming from the function header of the function. And in both cases, both in the Erlang and Elixir, this is an exported function. So basically, nearly any value can flow into this one. So this candidate became a vulnerability that's worth checking out and possibly fixing it. Over to you, Dali.
All right, thank you. So how does this all translate into the real world? What with Safe, we used our checkers to analyze 5 of the most popular open source projects, and we found that there is this significant number of vulnerabilities that we found. In the next slide, we will see that the most number of these vulnerabilities is going into the category of the denial of service. As Robert mentioned earlier, this category tells us that there are operations that are leading to an atom exhaustion that is being run on the system. And the next category is related to the injection of commands, of operations into the node without any sort of control into it. And the rest goes to deprecated calls with small percentage. And is it worth actually putting time and effort into securing the code base? Well, yes, because business continuity actually relies on this. So security vulnerabilities can lead to system crashes, service disruptions, even ransomware attacks. So a static analysis solution will help you to detect these issues really early on in the development cycle, and it will reduce the risk for the production issues and failures. It will also minimize the financial loss. And we all know that when your node goes down, you have the problems, security breaches, system failures. The downtime can lead to a significant financial loss, sometimes even with regulatory fines, loss of customers, and remediation costs. So a static analysis, as we described it here, like Safe, will help you to prevent these issues and save you a lot of money on the long run. System hardening. These kind of solutions will help you identify the security weaknesses before their deployment, meaning that it will allow the developers to build more resilient and secure Erlang and Elixir applications. This is particularly important for systems requiring high availability and fault tolerance, which is the most of the use cases for the Beam systems. Legal compliance. This is something very important because many industries have strict security regulations. I'm not only talking about GDPR or HIPAA, but other issues that could arise. The solution here helps to organizations to meet the compliance requirements and identify these issues really early on. And of course, the shareholder expectations, the investors will expect companies to actually take the security really seriously and invest in these sort of solutions that can demonstrate their commitment to the risk management on the long term. And the next. Okay, so why would you use Safe for your security solution? First of all, it's backed by university research. So Safe is partnering with a university here based in Budapest, and they have this tool that have been researched for a long time. And the secret sauce that actually runs everything is the data flow and the control flow. This will provide deep insight into the how the data moves and processed within the BIM application, and it will improve the detection accuracy, and will reduce the false positives by around 33%, and saves the developer the time eliminating this noise, and it will help them to focus on the real security risks. Yeah, so we have also the interactive report and visualization. This will make everything easy to put into place. For example, we can show you the application breakdown and what sort of issue you find in which application, and you can see this more clearly in the next slides. And the export of PDF is something that also can help you share these issues broadly in the organization with the team, the compliance documents or audit documents and so on. And of course, the CI/CD integration is a very important factor here because it will help you to keep, as we said, the development cycle always up to date with the security issues and vulnerabilities in the system. All right, so how did we actually define our checkers for these vulnerabilities? So for each of these categories, as was mentioned by Robbie, the security checkers are actually something that was defined by the security working group within the Erlang Ecosystem Foundation. And these are defined, of course, and you can visit the website and see why those issues are actually part of that weakness enumerability. So SAFE uses this resource to update and maintain the vulnerability analyzer so that we're always up to date with these issues. All right, so now if you would like to use SAFE in your system, of course, there is a possibility is that you can visit the documentation. You can download the desktop application. You can add your code base to it. Then the desktop application will know which part of the system you have and everything like that. And then it will generate a configuration file for you that you can use later. And this is, of course, free for open source. So if you already have a project that is available online and open source, you can use SAFE for free for it. All right. So partly it's about the web-related vulnerabilities. So we have this work in progress related to the web-based vulnerabilities. These are also defined by the Erlang Ecosystem Foundation, and we are currently implementing them. So meaning that there will be another webinar where we are explaining these web vulnerabilities in the same way that Robbie explained these denial of service or injection vulnerabilities. We will have those for cross-site scripting and so on. And they are also defined by the Erlang Ecosystem Foundation. You can visit this link and you can see the full list defined there. All right. So yes, including SAFE in your CI/CD pipeline, of course, it's a very important aspect, as we mentioned. So it's a very easy way to do it. You need to have the desktop application that would generate for you the configuration, and you need to have some CI/CD provider for it. So for us, we documented for GitHub Actions, Circle CI, and Semaphore CI. But if you have any other CI/CD provider that you use, we can also work around it because the SAFE uses the Docker image, meaning that it can be portable everywhere. Right. So this is just an example of how you can see the overview of the SAFE report. So when you run the analysis in your CI environment, for example, you will have the CI output, but you also get the report file that you can explore in your desktop application. This will allow you to see all of the vulnerabilities that were discovered in your system. You can explore them like you see there on the top with the categories, but also you get an overview of the application. So we do a breakdown, and then we show you that this particular application has this number of issues, and you can in that way really pinpoint which part of the system you should focus on more, and which parts seem to be more secure than others. And you can visually see that at the first glance whenever you have access to the report. And also we show you in the category itself. So if you explore the denial of service category, for example, to see what kind of atoms you are generating dynamically, we can show you, for example, the breakdown by severity. So you can explore it in that way. So this is something that that will give you more confidence, meaning that the system, the backend system that found the vulnerability, tell us that if it's in a high severity, meaning that it will be more probable to be executed and created as an atom, for example. So of course, everyone will start with the high probability ones and will continue and go down to the low severity. And you can see also the snippet of the vulnerability, and you can quickly see which type of issue it is and from which module it's coming from, and it gives you a quick glance on the issue. Of course, this tells you what is the problem, and we also give you a link to the Erlang Ecosystem Foundation guidelines, telling you what you should actually use instead and what is the background that led us to show you this type of issues. Of course, all of these vulnerabilities, as I said, are coming from some theoretical background, of course, and it will help you to understand, meaning that in the next time that you are writing a feature, you will be able to be more aware to not actually create this sort of issue in this way. And then it will help you in the development, meaning that SAFE is help you to uncover the vulnerabilities that are already in the system, but also gives you consciousness onto the whole security framework of your code base. And yeah, this is just the example of how you could see the vulnerability results after a CI job is finished. This will output you the list of vulnerabilities. As you can see, there is the low, moderate, and high severities. This means that the CI will gives you a warning, it will fail on this job, and then you have to fix these issues so that the next run you can see that they were corrected correctly. All right, so basically that's all. We just thank you for your attention for this webinar, and we expect that you can contact us. And if you have any more questions, you can find us at safe@erlangsolutions.com. Thank you very much.